Good afternoon. Today we'll look at the combination of the Slat Machine, which we documented last week, with the pack units, which allows us to specify the amount of program that goes into the slat and then packing it, in various sort of algorithmic ways. So the first thing to do is to just get the slat in, and as usual we can disregard the default, then extract the first parameter, which is the boundary, and assign the curve that I have already created, which will allow us to just have a very quick example. The only parameter that I will change in this demonstration is the width of the walls, anything from 0 to 30 right here, so that we can get a slightly more legible ratio of program to interstitial space. Having done so, we can then help ourselves to the slat pack units, which is right there, the component right next to this one. And we have to route parameter x with input x right there. So once you've done that, you can disregard again the defaults. We have to specify a number of rooms, okay, and the dimensions. So let's start with the dimensions. It's going to be a panel, a multi-line panel, and you just enter the dimensions in meters. So I'm just going to go 10, 20, and 30. So 3 types of rooms if you like. And right-click on the panel to make sure that it's typed as multi-line data. And then we can copy and paste this particular panel to specify the number of rooms per side. So we could have 3 rooms of 10, 6 rooms of 20, and then 12 rooms of 30. Okay? So we link this with the input of lengths, and then we link that with the input of amount. So something's happening. So the first thing to look at is you see there is a polygon sort of dangling there. This is because given the fixed side dimensions and the amount of program that we've specified, there could be some leftovers. In this case, there is 1. So the way you double check that is you can just create a surface component and link it with a leftover parameter, and then you can see you can click on it. This is the leftover given the amount of program we have specified. So there's various ways you can fix that. You can, for instance, make a slightly smaller corridor. A larger wall allows us to get rid of the excess parameter there. So once this is done, then we can just extract now the program that we have created. So units are actually groups. So the first thing to do is to double check exactly what the type of the output is. So you create a panel and list it there, and you can see that it's 3 sublists which form a master list. So in order to eliminate, if you like, the master listing, you can simply flatten the output, which means that now we have a single list with 3 components, each of which is a group with 3 objects. And having done so, we can now then choose a list item to help ourselves to the first item of this list, which is going to be this one here. Okay, and then we can make a slider for the index as well. So you see this is the first one because we default at 0, which if I click on it is over here. You see these 3 spaces? These are spaces that are 10 units deep. It's the 3 that I have highlighted here. Okay, this is the first element of our list, and then if you move the cursor, you can see that we can actually select, in this case, the third component, which is a group with 12 objects, 12 spaces of 30 meters depth. Okay, so having done this, so these again are groups, so we need to ungroup them. Create an ungroup component, and now the output is actually an individual curve or surface, so we could just extrude it right there, select this, and then of course we have to specify an extrusion vector. Let's just take the unit z vector, and of course we have to change the magnitude from a default of 1 to maybe something that's a little more legible. Anything between 0 and 20, okay, which allows us to visualize that third program item, which is 12 rooms of 30 units wide. And of course now any changes that we make to the parameters would automatically be reflected. You see? Now, one thing that you may want to consider right there is this last parameter of jitter. This is just a way of reorganizing the sorting. So the packing takes place with certain parameters, and you can simply rejig those parameters, okay, by changing this value, which is a real number between 0 and 1. And you can just, you see, rejig it, and you see that as I change this particular decimal value, I get a slightly different distribution, which is, again, the algorithmic approach to optimizing both the packing and, of course, examining the relative position of these different program boxes. That's great. Thank you very much.